Okay, question 19 features a rectangle, base x, height y. We know that the area of the whole shape is r, and we know the perimeter of everything is 100, at last a number. Okay, and we've been asked to show that the area is in terms of x. Notice it's not in terms of y, so we're going to have to get rid of y. And incidentally, we're told that, yes, this is an equilateral triangle. So all three sides are equal, which means, of course, this is x and this is x, if the base is x. So if I drop a perpendicular down to the line DC, this will meet at a right angle. Let me call this area 1, and this is area 2. And we know this is another 1 effectively. So I can say that 2 times area 1 plus area 2 is equal to r. So let's get the easy one out of the way. Area 2 is equal to xy. The length of my perpendicular I'm going to call h. Now, this is an equilateral triangle, which means that this angle here is 60 degrees. And this is 30 if we need it. And this is the right angle. And tidying up the bottom, this is x over 2 to here. Okay, area 1 is equal to a half the base multiplied by the height, which is equal to the base being a half x, so this is x over 4 multiplied by h. So what about h? Well, h can be found by the fact that we have an opposite and a hypotenuse, the sine relationship of 60. So I can say that sine 60 is equal to the opposite, which is h, over the hypotenuse, which is x. So therefore, h is equal to x times sine 60. Sine 60 should know as root 3 over 2. So this is x root 3 divided by 2. Okay, so I can now say that area 1 from here is equal to x over 4 multiplied by x root 3 over 2, which is equal to x squared root 3 over 8. So let's try to find out what r is now, what r has become. R is equal to twice area 1, so this is x squared root 3 over 4, because we've got 2 of these area 1s, and plus area 2, which is xy. How are we doing? Well, we've got various bits appearing, but not quite right. But we haven't used one fact. And the fact we haven't used is the perimeter equals 100. What is the perimeter? How many x's? 1, 2, 3. So I can say 100 is equal to 3x plus how many y's? 2y. We want to eliminate y because y does not appear in the expression they've given us for r. So let's make y the subject. Therefore, 2y is equal to 100 minus 3x, and y is equal to 100 minus 3x, both divided by 2. So with that result, I can pop that into my expression for r and see how we go. So I get x squared root 3 over 4 plus x times this lot, which is 100x minus 3x squared, both divided by 2. So effectively, we've got 3 terms here. We've got x squared root 3 over 4 plus 100x over 2 minus 3x squared over 2. Now, what have they done? They've taken a common factor of x over 4 out, so let's do the same. So if I take an x over 4 out of everything, I get x root 3 plus If I take x over 4 out, what I'm left with here is 200 minus, again, I'd have to multiply the top by 2, so this becomes 6x. Now, if we look at this term by term, here's our x times 200, so that's there. So x over 4 multiplied by negative 6x, so that term equates to this term. And bringing up the rear, x over 4 multiplied by positive root 3x. So this term matches up with this one. So even though the two results look a little bit different, they are in fact one and the same, and that is your answer for part A. So for part B, I've cleared the decks, and we're asked to find a value of x for which r is a maximum. Give your answer in the form of this, where p and q are integers. Okay, well, to find out where this expression is a maximum, we will have to differentiate and then set that differential result, that gradient function as it is, to 0. So first of all, let's multiply these things back out again. So it's that multiplied by that multiplied by that. And let's say that's equal to y. So therefore, dy dx is equal to 2 multiplied by root 3 over 4, x plus 50 minus 3x. So to find the value of x at the turning point, we need to set this expression to 0. I'm going to multiply through by 4, so I get 2 root 3 x plus 200 minus 12x is equal to 0. So pulling a common factor of x out of our two terms, so I get 2 root 3 minus 12 is equal to negative 200. So therefore x is equal to negative 200 divided by 2 root 3 minus 12. Which, if we just multiply all the way through by minus 1, is 200 divided by 12 minus 2 root 3. Which, if we take a common factor of 2 out, is 100 over 6 minus root 3. And those are your two answers. So for part 2 of B, we have to explain why the point we've found where the curve has a turning point is a maximum. Well, you need to look back at the original curve. This is, if you look at the x squared terms, the x squared terms have a negative coefficient. And with a negative coefficient, the curve must be an n-shaped curve. So the point we've found, which is here, must be the point of the maximum. So to get your marks, you have to write that down. You've got to basically say that the coefficient of the quadratic here is negative, therefore it's an n-shaped, and the point we found, which is the turning point, is a maximum. And that will get you full marks.